This task is from our solving linear equations unit. More specifically, this one's focusing on variables on both sides. We used this as an introduction to that unit. So when we gave our students this task, we didn't expect that they were going to write the specific equation with variables on the left and right side perfectly. We honestly just expected our students to use what they know about equations and solve for the unknown and then be able to apply that back to perimeter. We did have some students that set up an equation and were able to do it that way, but not everyone did. So when the students look at this task, they're going to identify that we're kind of looking for more than one piece here. So we know that the square and the rectangle have the same perimeters. We only had a couple groups out of over 20 that made the mistake of using area instead of perimeter. Now, if we look at what we're given about the square and the rectangle, we know each side of the square is 4x minus 1, the length of the rectangle is 2x plus 2, and the width is 2x. What a lot of our students did was they almost did just a guess and check system, or they used their basic additive strategies. So they kind of looked at it as 4x minus 1 plus 4x minus 1 and kept doing that, which is okay. We're not trying to make them focus on one set strategy right now, because our students that did use that additive strategy were able to figure out and solve for the x as well as the perimeters. Now, when I'm writing just my normal answer key to have, I had set it up as, 4 times 4x minus 1, and then I have the 2 and 2x plus 2 plus 2 times 2x. Now, this is something that we more got to in the consolidation piece. We didn't really expect our kids to write it out this way, but they have to understand that there's more than one piece to find right now. Some of our kids just plugged values in to see if they could figure out what x would be so that all the sides of the square added together equal all sides of the rectangle added together. So what they should get to is that x equals 1. Then they have to apply this back to the square, and they have to apply this back to the rectangle to figure out the total perimeters. Now, the perimeter for the square and the perimeter for the rectangle should be equal to each other. So if x does truly equal 1, when they plug it back in, they should be able to determine that the perimeters should be 12. When we were walking around and checking on groups, we just wanted to make sure and verify that they were indeed using perimeter and that they were taking into account that the 4x minus 1 should appear 4 times, and that 2x plus 2 is 2 times, and the 2x is 2 times, no matter what format their thinking was in. Then with the consolidation piece, when we bring everyone back together, we're asking a few questions just to make sure that we understand the pieces, and if someone in the group maybe did not feel as confident about the material, that they have the opportunity to hear this information again. We asked, how do we find perimeter? All right, just to make sure we have no more errors with area versus perimeter. Then we looked at, we know that the perimeters are equal to each other, so tell me in words what that means for the equation. Because sometimes our students can explain things to us verbally, but they're struggling to put it in a mathematical sentence. How do you set up the problem? Now, this could have been done many different ways, and usually we have several groups picked out that we said, hey, we want you to share this piece because their thinking is really interesting, or it was different than most of the rest of the class. We also asked, could you have solved it without writing one specific equation? Meaning, instead of writing what I did over here, could you have still solved it? And then what exactly is the missing piece representing? So just some thinking questions to bring them back together. And we do ultimately, in that consolidation piece, show them different ways that we could have written out that equation.